Hello everyone, Mr. Scullin here. We are back at it for Unit 2, Lesson 7, and today we're solving three-dimensional systems. Using substitution, you have experience with substitution before, just in a 2x2 setting, and so this will be slightly different, but the main idea is the same. We are going to try to get in the limit, we're going to try to get a variable by itself equal to something, and we're going to take that something and we're going to substitute it in to something else, and what we're going to plug that into is our system of equations. We are still doing systems, and so of the 3x3 variety, remember our goal is to with the 3x3 we always want to go from a 3x3 and try to move into a 2x2, and then once we get the 2x2 we're going to try to get to the 1x1, which is like x equals 5. And then we always just want to work backwards to plug it into the 2x2 to get the second variable, and then plug both of those variables back into an original 3x3 to get the last variable. So with substitution, what you want to do is you want to look at your three equations, and I always like to label just to stay organized, and you want to figure out or look for a variable that is by itself with no coefficient or number in front of it. So there's plenty of options here when you look at this first example. For me, I guess I'm going to look at equation 1, and I'm going to get x by itself, so I'm going to take this first equation and I'm going to add 3y and subtract z to the other side and leave the 6 over there as well. So I'll have x equals, and I'll have a positive 3y minus a z and plus 6. And now that I have this by itself, this x by itself, you're going to plug this in wherever you see an x into the second and to the third equation. So the gist of substitution works like this. You're going to find one of the equations, get a letter by itself. Once you do that, you're going to plug what you get for your variable equal to into the other two equations that you did not manipulate. So I manipulated equation number 1 by getting this x by itself, so I'm going to plug whatever I get into equations 2 and 3. If I would have gotten y by itself here, I would have plugged whatever y equals into equation 3 into equation 2 into an equation 1. So here's how this works. I'm going to plug this now into equation 2. So I'm going to go 2, and now x is not x, it is 3y minus z plus 6, and I put that in parentheses. Whenever you use substitution, my suggestion to you would be to always use parentheses so that you know when you're going to have to be able to distribute and or run negatives through the entire quantity. Minus the 5y minus z equals negative 2. So then I distribute, that's 6y minus 2z plus 12 minus 5y minus z equals negative 2. Now we got to put some like terms together. 6y and minus 5y is going to give me just a regular y. Negative 2z and negative z would be negative 3z. And I have, let's see, a 12 here. I'm going to subtract 12 to the other side, so that's going to give me a negative 14. And again, my whole goal when doing this is to try to get it into a 2x2 equation, which I have done. So I'm going to kind of just box this up right here for now. It's not my answer or anything like that, but that is from plugging in x into equation 2. So some students, I'll see stuff like this. They'll say, okay, here's x into equation 2, and now they're going to take x and plug that into equation 3. Right, if they like to stay organized. So now I'm going to have a negative sign, and then I need to put a parentheses, and then now plug in x, which is 3y minus z plus 6 plus y plus 2z equaling 7. Now again, I use parentheses all the time when I substitute in, so now I'm going to run this, and it's really like a negative 1, right? So I'm going to distribute that negative 1 through, so that becomes negative 3y plus z minus 6 plus y plus 2z equaling 7. Again, this negative 1 would only be distributed through what is in parentheses. This plus y and plus 2z stay as is. And just like we did before, we want to combine our like terms. And so I just want to take a peek here on the left-hand side of the equal sign. Negative 3y and positive y would be negative 2y. I have a positive z and a positive 2z, so that's going to be a positive 3z. and I'm going to add 6 over to my 7 and get 13. And that should be my second equation of a 2 by 2. So those two boxed equations I'm going to take up over here and rewrite to form my new 2 by 2. And as soon as you stack these, you'll see something really nice for this problem. This doesn't always work out this way, but for the sake of the example in time, picked one that does. If you look at these two, and again, I like to add my two equations once I have a variable that I can eliminate. Now, some of you are going to say, oh, you're using elimination. I'm just going, yeah. What we want to see as teachers is your ability to use the substitution method to generate your 2 by 2 system. Once you've generated the 2 by 2 system, which I have here, you can go back to using whatever method you see fit. I could have easily added 3z to the other side and used substitution to solve this, but for me, for my money, whenever I'm doing system work, I'm going to try to solve by elimination because I think it's a little bit easier. I know there are a lot of students, I've come across a lot of students in my time teaching who, when they do three-dimensional systems, will use substitution because they feel it generates the two equations a little bit more soundly than elimination. There's a little less room for error, and then they go back and do elimination kind of like I am here. And if you find that to be the case for you, go for it. But we definitely want to see you use substitution for the first step to get your 2 by 2. All right, let's carry on. I add these together, so I get a negative y, and that's going to be, what, a negative 1 there, so y should equal 1. And just like we did before, once we find our 1 by 1, now we go back to a 2 by 2 and plug that y equals 1 into any of these. So I'm going to plug it into this 2 by 2 that I got, so that's going to be 1 minus 3z equals a negative 14, so I'm going to subtract 1, so going to be negative 3z equals a negative 15, and z is going to equal positive 5. And now I can go back to any of the three original equations and plug in y for 1 and z is 5. So I'm going to go back to equation 1. So x minus 3, my y is a 1, plus my z, which is a 5, equaling 6. So it's going to be x minus 3 plus 5 equals 6. And that's going to be x plus 2 equals 6. So x should equal 4. And again, we go alphabetical order. So x, y, and z. There's your answer. Again, what should you always do? You should always check these just to make sure. Plug those back into all three just to make sure you are doing the steps correctly and that you haven't generated an incorrect answer. For the sake of time, I'm going to break my own rule and not check those because it's right. All right, on the back, at least I hope it's right. On the back, just one more quick example. Once you kind of get the hang of these, they should go down pretty quick for you. Why don't you go ahead and hit pause, try it, and then check back with me here in a minute and hit play to see if you have done it correctly. Okay, so it's the same kind of deal here. We're solving by substitution. Again, I want you to show substitution to get your 2 by 2, and then you can use elimination. By then, again, I'm numbering my equations. So I'm going to get z. I'll just pick a different letter. I see this z by itself, so I'm going to get z by itself this time. So I'm going to have z equals, I would subtract the 2x, subtract the 3y, so minus 2x minus the 3y, and that minus 4, which is on the right-hand side, still stays over that way. So this is what I'm going to take and substitute in for z into equations 2 and 3 because I manipulated 1. So here's what it looks like. Equation 2 now is x minus y minus 3 times, in parentheses, negative 2x minus 3y minus 4 equaling 1. So x minus y minus 6, that's going to be a plus 6 because I'm going to take this negative 3 now. You've got to be careful here. I almost went too fast. X minus y, that's a negative 3. So that negative 3 has to get distributed. Negative 3 times negative 2x is positive 6x. Negative 3 times negative 3y would be a positive 9y. Negative 3 times negative 4 would be a positive 12 equaling 1. And so what I get here is my like terms. X and 6x make 7x, minus y and 9y make 8y, and I'm going to subtract that 12 to the other side, which would give me negative 11. So that's 2 by 2 equation number 1. I'm going to take z, and that was plugging again. Some students will go, they'll plug z into equation 2, which is what I did here. So now I'm going to take z and I plug that into equation 3, which looks like this. 3x plus 2y plus 2 times negative 2x minus 3y minus 4, and that's going to equal 5. So 3x plus 2y minus 4x, 2 times a negative 2x, 2 times a negative 3y would be negative 6y, 2 times negative 4 would be negative 8, equaling 5. My x's, 3x negative 4x is negative x. My y's, 2y negative 6y would give me negative 4y. Add 8 to 5, which would give me 13. And here's my second equation. Okay, now I have my 2 by 2s, so now I need to stack these and solve. So I'm going to kind of work over on this side of the paper. So 7x plus 8y is negative 11, and negative x minus 4y equals 13. And now I have my 2 by 2. Now I'm going to use elimination here. I'm going to multiply that second equation by 2, which will give me negative 2x minus 8y, and that'll give me 26. And I'm going to add those two together. I like to add my variables, so that's going to be 5x equaling 26 minus 11 should just give me 15. So x should equal 3. All right. And now once I have that, I can plug it back to either of the originals. So I'm going to use, I'll plug it back into this 2 by 2, which I had here. So that's going to give me a negative, and then my x is now 3 minus 4y equals 13. So I'm going to add 3 to the other side. That's going to give me negative 4y equals positive 16. So y is going to equal negative 4. And then once I have my x and y, I can pick any of the original and plug those in. I'll use equation 2 since I see some small variables there. So I'm going to have a 3 minus my y, which is a negative 4. Again, good use of parentheses when substituting in to see things. So I'm going to have 3 plus 4 minus 3z equaling 1. 7 minus 3z equaling 1. Let's see, I'm going to subtract 7 from both sides. Negative 3z, hopefully I'm still on the paper, yep. Negative 3z equals a negative 6. And I'm going to divide by negative 3. And so z is going to equal positive 2. Okay, so x, y, and z, I'm going to have x, y, and z. Put those in parentheses, and there is our answer. As always, make sure you take a couple seconds to check. We're trusting that it's good. And that is how you solve systems by substitution. Just quick review. Make sure you use substitution to get your 2 by 2, and then once you get your 2 by 2, notice here I did elimination. You can use any method you want to solve once you set the problem up into a 2 by 2. If you have questions, always happy to help you out, and I'll see you in class.